In this video, you'll learn to adapt BERT models for specific industry domains, acquiring skills to process legal or medical texts effectively. Do you know that fine-tuning BERT can drastically improve its performance in specialized fields like law and medicine? In this video, we'll explore how you can adapt BERT for domain-specific tasks. From understanding the unique challenges of domain language to evaluating model performance on custom datasets, we will cover it all. Whether you're working with legal texts or medical records, by the end of this video, you'll have the skills necessary to make BERT work for you.
Domain-specific languages are rich with unique terminologies, technical jargon, and context-specific nuances. For instance, terms like plaintiff or defendant are common in legal texts but may confuse a general NLP model. Similarly, medical texts often include complex terms such as hypertension or myocardial infarction, requiring precise understanding. These challenges necessitate tailored approaches for processing such texts. In this section, we'll delve into these challenges, helping you understand the impact they have on NLP models and how fine-tuning BERT can address them. BERT, which stands for Bidirectional Encoder Representations from Transformers, is a game-changing model in the field of NLP. Its transformer architecture allows it to understand context by considering words in relation to all other words in a sentence. This bidirectional approach makes BERT highly adaptable for various NLP tasks. Pre-trained on vast amounts of data, BERT can be fine-tuned for specific domains, leveraging its extensive language understanding while adapting to the nuances of niche domains. In this section, we explore how BERT's architecture supports this adaptability, making it ideal for tasks ranging from sentiment analysis to complex domain-specific language processing. Effective data preparation is crucial for fine-tuning BERT models. Start by selecting relevant datasets that accurately represent your domain. Ensure data quality by eliminating errors and inconsistencies. Pre-processing steps such as tokenization and normalization are essential to prepare data for BERT's input format. Handling imbalanced datasets, where certain classes are overrepresented, is also vital for model accuracy. By meticulously preparing your data, you set a solid foundation for successful model training, enabling BERT to learn domain-specific language intricacies effectively. This section provides a roadmap for preparing your data to fine-tune BERT for niche domains.
Choosing the right hyperparameters is a pivotal step in fine-tuning BERT models. Key parameters include learning rates, batch sizes, and dropout rates. A smaller learning rate ensures gradual, stable training, while appropriate batch sizes balance computational efficiency and model performance. Dropout rates prevent overfitting, crucial for models dealing with domain-specific language. Experimenting with these parameters allows you to tailor BERT's training process for your specific needs. Optimizing hyperparameters enhances the model's ability to understand and process niche domain texts effectively, ensuring high performance in specialized tasks.
Leveraging pre-trained models offers significant advantages in fine-tuning BERT for niche domains. Pre-trained on vast datasets, these models have a comprehensive understanding of language, serving as a robust foundation for further adaptation. By using pre-trained models, you save significant time and computational resources compared to training from scratch. Adapting these models to your specific domain needs ensures they incorporate the necessary domain nuances while benefiting from extensive prior knowledge. This section guides you on how to efficiently utilize pre-trained BERT models, maximizing their potential for specialized tasks. Evaluating model performance on custom datasets is crucial for assessing its effectiveness in domain-specific tasks. Start by setting clear evaluation metrics, such as accuracy, precision, and recall, tailored to your domain needs. Use confusion matrices to gain insights into model predictions and identify areas for improvement. Iterative evaluation and refinement ensure the model continually meets domain requirements. This evaluation process not only validates model performance but also guides further fine-tuning efforts, ensuring your BERT model performs optimally in processing specialized texts.
Overfitting is a common risk when fine-tuning models on domain-specific data. It occurs when a model learns the noise in the training data rather than the actual patterns, leading to poor performance on new data. To prevent overfitting, implement dropout techniques during training, which randomly deactivate neurons to promote generalization. Early stopping, where training halts once performance stops improving on validation data, is another effective strategy. Regularization methods, which add penalties for model complexity, also help maintain a balance. By applying these techniques, you ensure your BERT model generalizes well to unseen domain-specific texts.
Deploying your fine-tuned BERT model in real applications marks the transition from development to practical use. Begin by preparing the model for deployment, ensuring it meets performance and scalability requirements. Integrate the model with existing systems, considering factors like data flow and processing speed. Post-deployment, monitor the model's performance, addressing any issues that arise. Regular updates and retraining are essential to maintain accuracy as domain-specific language evolves. By effectively deploying and managing your model, you ensure it remains a valuable asset in processing specialized text for practical, real-world applications.
Congratulations! You've learned how to effectively fine-tune BERT models for niche domains. From understanding domain-specific challenges to deploying your models, you've covered essential steps in adapting BERT for specialized tasks. Remember, domain adaptation is crucial for creating models that truly understand and process nuanced language. We encourage you to continue experimenting with different techniques and share your experiences in the comments. Don't forget to like, share, and subscribe for more insights into the world of NLP. Let's continue this learning journey together.